Yep, so thanks everyone for giving me the opportunity to speak today. So my name is Matthew, I'm a final year PhD student at the University of East Anglia, and today I'm going to talk to you about my broad PhD topic about the PTM, but because it's a weathering conference, looking at the sort of evaluating the drivers and the interactions chemical weathering could have was taking place during the PTM. So what do we know about the PTM and why is it important interval to study? So as we've heard, PTM, Paleocene-Eocene Thermal Maximum, occurred 56 million years ago, and it provides one of these best geological analogues for understanding how chemical weathering could respond to abrupt changes to global warming and the global carbon cycle. Previous studies have looked at, have evoked different mechanisms in driving chemical weathering during the PTM. Earlier work has proposed relative sea level changes, which you can see in that sort of top diagram. But more recent work has been looking more on a hydrological cycle focus in driving intense weathering. We can see in this study at the bottom there that we actually, a lot of locations during the event saw an increase in mean annual precipitation, which both could have been involved in driving this enhanced flux of continental weathering that we see. To add some more intrigue to the story, in particular locations such as the Tethys, sort of central Eurasia today, we also see evidence of organic rich sapropel horizon, which we can see observed here, which suggests also evidence of organic rich deposition during the onset of the PTM. And it's we still don't really know how these different processes are interacting between chemical weathering, organic carbon burial, and the wider Earth system changes going on at the time. So my project's looking at this Kheu River section in the northern Caucasus to sort of get a better insight of kind of combining these records together and getting a handle on what's going on. So what kind of weathering records currently exist for the Kheu River section? So one of the initial records produced was this chemical index for alteration proxy for weathering, produced back in 2014. And what we can see in this diagram here is that the authors were arguing that we see this influx in the values of the CIE proxy kind of coeval with the onset of the PTM carbon isotope excursion. And they were arguing this was representing an influx of weathered trial clays. But what you may also notice is that there's a lot of variability within the proxy, especially within the main carbon isotope excursion. And there's also this overall increasing trend up sequence. And yet, currently, there's not any explanation for these variations, and they remain largely unexplored. So for a following year, in 2015, a second study came out, and this time they used osmium isotopes, so this sort of radiogenic isotope proxy for weathering. And this record was used to argue that there was an increased flux of radiogenic osmium into the global ocean during the PETM, and this would be a sign of enhanced continental weathering at the time. But despite this, however, any prospect of disentangling any lead-lag relationships between global carbon cycle changes and those driven by continental weathering remain elusive because of the unfortunate poor age constraints on this section. So far, the kind of getting a handle on the kind of relationships in a more high resolution remain elusive. So this is something that, as part of this project, we hope to look at, and this is a lot of detail, different data sets. So I'm just going to sort of quickly move through this, but we thought it would be a good idea to implement a sequence stratigraphic framework, especially if we're thinking about the that first open question about what was driving the weathering. Was it a sea level change or was it a hydrological cycle change? So what we can hopefully see is that we do pick up these covariations in both the sort of chemostratigraphic and microfossil datasets within the Kheu section. And we interpret these to represent sort of conventional transgressive systems tracks, or sort of transgressive like sea level rises and regressive system tracks, which there's several that's been interpreted within the section. We also identify maximum flooding and maximum regressive surfaces using sort of the maxima and minima in the amount of planktonic foraminifera, which are found in the section as well. And they sort of correlate well across the records. Interestingly, what we found was that although the sapropel horizon is deposited during a time of sea level rise, it does not equivalent a maximum flooding surface, sort of kind of questioning previous interpretations. The other point that was raised was the lack of a poor sort of temporal resolution. So we actually, because there's a lot of detailed biostratigraphic work done by other authors in this section, we thought it'd be an interesting idea to sort of bring in an orbitally tuned age model and tie in using the tie points as the different bio horizons as tie points. And this was done through the an orbitally tuned age model produced from the deep sea site 1262, which is a really good site for kind of orbitally tuned age models of this age. And we were able to bring those records together using the sort of calcareous nanoplankton bioevents. And this actually produces a sort of temporal resolution anywhere between 1 in 83, 1 in 183,000 years, with obvious an increase in sedimentation rates around this sort of black shale horizon. If we compare our bulk carbonate carbonate record to the global one at 1262, we actually see that this age model plots them fairly well together, and we actually see that the Kheu River section is actually responding to about a time slice of about just over 1 million years of time. And we're getting the PETM in there, but there's also the prospect that we're picking up a slight earlier carbon cycle perturbation, a smaller one called the D1 event. When we bring in the CIA record into the new age model, we can actually start to tease out some timings on the kind of what these variations were showing and when. So pretty much in the latest Paleocene, we're actually seeing that there's this overall increase in the CIA records, which could represent this increase in global weathering, if that's what you are believing. We can see that as we enter the PETM negative carbon isotope excursion, there's this maxima in the CIA values, reflecting potentially a temporary transition into a more intensive chemical weathering regime. But interestingly, that trend continues on after the main carbon isotope excursion into the earliest Eocene as well. Potentially could be interpreted to reflect a more enhanced weathering over the entire record. But when we bring in the osmium isotope curve, we do see some clear differences. So sort of in the previous 400,000 years prior to the PETM, the osmium isotope record is quite stable around 0.32, suggesting a more unradiogenic global ocean during the latest Paleocene. As we enter the PETM, we get this increase in the osmium isotope values before this overall decline to more unradiogenic values in the earliest Eocene. And this is the evidence used to suggest this increase in enhanced continental weathering globally at the time. And yeah, you might have recognized that if in the blown up version of this, there's actually a temporary decline in osmium isotopes at the base of the PETM, which previous authors have suggested could reflect an increased pulse of basaltic weathering related to the North Atlantic igneous province. And this age model suggests it was within error of the first 10,000 years of the event. So as being a weathering conference, and we're thinking about one of the objectives was that any advantages of paleo-weathering proxies would be this idea of pairing different paleo-weathering proxies has the advantage of being able to show distinguishing these trends between regional and global signals. So what we can see when comparing the two different paleo-weathering proxies is there is indeed a global weathering signal during the PETM CIE, which the age model suggests was within the first 26,000 years of the event. And this would suggest then that the regional and the global records are responding to a kind of same causal link, potentially a hydrological driver. However, the longer term trends in the CIA curve are decoupled from that of the osmium, and this could be potentially suggesting that the CIA curve is in fact biased by potentially changes in relative sea level over longer timescales. And we can actually see that the sort of stepwise increases in the CIA seem to follow sort of the regressive systems tracks when the sea level fall. So there are various ways where you can actually screen your CIA records to see if there is any bias. And one of the main ones that some authors have suggested is the fact of grain size can actually significantly bias the CIA interpretations, because any increases in grain size can directly impact the chemical composition of the sediments analysed. So to test this, we ran the CIA record against a grain size proxy, the zircumrubidium proxy, which has been shown to be an effective grain size proxy in sediments. And as you can see from this figure here, there's only a weak correlation. So potentially there's some influence for grain size in the records, but it doesn't seem to be the main factor driving the variability within the CIA curve. Another idea that some authors have suggested is the impact of detrital feldspar species, because they too also can bias the CIA through changing the concentrations of key elements within the CIA equation. And again, we did this by sort of comparing CIA to the abundances of sort of potassium feldspar. And what we do find is, as you can see, a strong correlation between feldspar content and CIA. And this could suggest that the Kheu River sediment source is actually some sort of highly weathered mature soil, potentially. That's one interpretation. There's a lot of other things we can do. So for example, we can look at the sort of provenance idea of looking what was the parent material that these sediments came from. And they sort of plot within the sort of felsic to intermediate parent rock type, which isn't too crazy an idea. And actually, when you put this on sort of paleogeographic reconstructions of the sort of region at the time, it actually implies that the parent rock type might be the sort of crystalline basement of the sort of Eastern European platform, or the Donets High, which were to the north of the sample site. And the sediment influx was coming from the north, not from the sort of volcanic island arc to the south, which was sort of an interesting interpretation. So provenance is another thing that can impact the CIA records. So any changes in provenance could then change your lithology in your source area, and that could also impact CIA. So again, we screened CIA against aluminium-titanium ratios, which is one of these ideas to track for any changes in sediment provenance. And as you can see, no correlation was found. So we suggest that the provenance of the Kheu sediments at the time were consistent from the same parent throughout the entire site. So there is other evidence of things going on at this site as well, which is interesting to consider when compared to the chemical weathering. So there's a clear faunal shifts within the benthic foraminifera communities during this time. A sort of intermittent increase in sort of high nutrient conditions in the bottom waters of the site, with these interesting stress tolerant forms coming in. And you can see that sort of correlates nicely to the sort of variable intense peak in CIE values, suggesting that potentially we're getting a regional weathering and nutrient delivery, which is directly responsible to these sort of like changes in the benthic ecology. And yeah, one interpretation of this could be that the nature of these records is that we're actually seeing some sort of seasonal variability in precipitation, which is driving an influx of nutrients at different points within the onset of the PETM. If there is other evidence as well to consider, things like the sedimentation rate, which actually shows a huge increase during the sort of onset of the PETM, which is quite common in other locations. And an increased sedimentation rate supports more a hydrological driver, because if it was a transgression, you would expect there to potentially be a condensed section with sea level diluting sediment input, but we are seeing the opposite signal here. There is very few independent sea level estimates for this period, but one of these records I did find that was able to be brought into this age model is one by Miller in 2005. There's big error bars on the amount of sea level estimated during this time, but the sort of general idea is that the transgression at the PETM happened somewhere between 56.1 and 55.8, which actually does sort of overlap with our interpretations of the transgressive systems tract, which we kind of refine this down somewhere between 55.93 and 55.87 million years ago, and that's using that age model that we're using. However, the maximum flooding surface, which is defined at the top of the E1 foraminifera biozone, and the peak in the sea level curve, as you can observe, occurs after the peak in the CIA records. So this suggests that the peak in global sea level may have occurred after the initial weathering pulse, suggesting it might have not been involved in driving chemical weathering. There is more evidence to link a hydrological driver to driving the enhanced chemical weathering during the PETM. Some new data we've plotted up here is the correlation between the osmium isotope record and the example of a paleosalinity record. This is sulfur TOC. And as we can see, there's a large shift to more fresher values, suggesting that when we did see this increase in the hydrological cycle, driving an increase in continental weathering globally, locally at Kheu River, we actually see a freshening of the water mass at the time. This was quite important potentially when we think about our organic carbon burial, because the freshening water mass signal is actually also concurrent with an increase in the total organic carbon that was buried at Kheu River during this time. And we were getting to quite high values, almost about 9% And you can actually see that this is also concurrent with the peak in the osmium isotopes as well. So again, suggesting that this could have been an intensified hydrological driver driving all these things. The coeval nature of first of all, the increased continental weathering alongside the enhancement of organic carbon burial at Kheu River highlights this complex Earth system interaction that might have been driving a lot of different things during the PETM. And we can see that an increased hydrological cycle can lead to increased silicate weathering, runoff and erosion. Those nutrients will enter the shallow marine environment and through other processes can result in enhanced organic carbon burial. So just to conclude off, some key points to consider. So the existing variability in the paleo-weathering records and the lack of temporal resolution at Kheu River has now been addressed through both a sequence stratigraphic framework and a calibration to an orbitally tuned age model. Both the CIA and osmium isotope paleo-weathering proxies potentially show this enhanced continental weathering episode within the first 26,000 years of the PETM CIE. And we suggest this is reflecting an intensified hydrological cycle as the driver and not a transgression. Some clear advantages exist between pairing different types of paleo-weathering proxies. And in doing so, we can actually start to disentangle potentially regional and global signals, and also importantly screen CIA records for potential biases. And last but not least, the coeval nature of the increasing global continental weathering, alongside the regional enhancement of organic carbon burial, suggests that there's these very complex Earth system interactions that chemical weathering was potentially involved in, especially within the shallow marine environments during the PETM. So I'd like to open to any questions. Thank you.
I was just going to ask, so we have the CIA values during the PETM, and a bit like there's a lot of variability.
Yeah.
Compared to the rest of the record, and sample at higher resolution. I just wondered, I don't think you zoomed in on that. Is there like a pattern, like the orbital pattern in that, or is it just noise?
Yeah. So that's quite interesting. Yeah. So there seems to be within the CIA records these two distinct peaks, and they sort of do almost look reminiscent of the two peaks in the organic carbon. So using this age model, the entire sapropel would be on order of about 26,000 years. So those variable cycles would be, assuming that's the age model you're using, would be less than that. So they probably would add suborbital cycles. I don't know what they would maybe be reflecting, maybe, but that's why I've suggested seasonal, but it's anyone's guess, I think.
But there are two distinct peaks. I looked like
there are two distinct peaks, yeah. But that age model would suggest that they would be on the order of a few thousand years in duration. So it's interesting to think what that could be driving that. But yeah, again, the correlation to the sort of ocean 1262 record suggests that they match up quite well. So yeah.
Matthew, did I see that right? I thought you were showing the CIA was going down at that time. Shouldn't it go up? Or did I misread that?
Which ones?
We saw that. Yeah, CIA, isn't there?
Yeah.
The E1 phase is going down.
Yeah, so this is
less way, not more.
Yeah, precisely. Yeah, so we do have these two transient peaks in the CIA, but as you note, there is a lot of variability, and some values are lower. So yeah, it's quite interesting, because what we're actually seeing here, if this was to be interpreted a more sort of grain size, you're going from high sort of grain size down to lower grain size. It's almost tracking your sort of transgressive package. So this is where the potential biases coming in from. So there is a longer term sea level rise at this time that would impact maybe your coarsening of your material, but that might also be reflected in the overall signal as well. Yeah.
I guess maybe you talked about it, so I didn't notice. I just wondered if it was like a direct impact of the climate change, or is this recycling?
I would probably think more the latter, the recycling idea, because there is a lot of different independent proxies that support sea level variations at this time. So, and also this is a sort of middle shelf sort of record, so that any hydrodynamic sorting or anything you'd expect would probably likely have occurred by then. So there's probably some other processes that are interfering with that signal, I would say. That's one of the kind of annoying bits about the CIA record, is it's quite useful, but equally there's a lot of different things that can bias it. So.
A stupid question to start with, which is, why is sea level changing? Is it just this site? And then the second question is about the osmium isotopes. You know, that new data looks really variable at that lithological transition.
Yeah, yeah.
Just, you know, how big are those excursions compared, you know, are we looking at noise there, or is that real variability?
Yeah, so I think that, yeah, the sea level, so the first question there about the sea level, there is growing evidence of like fairly large amplitudes in sea level. These packages have been correlated across the sort of central Eurasia, so that there is evidence of large amplitude sea level fluctuations at this time. Some of Miller's more recent work actually controversially suggests the potential of small ephemeral ice sheets, which is a bit crazy to think about, but thinking about of sea level fluctuations, there was potentially an order of magnitude of tens of meters of sea level rise over for a few 100,000 years potentially. So what's driving that is anyone's guess. I think there's still a lot more work that needs to be done. In terms of the osmium record, those osmium, the osmium increase is correlated to other sections within the Peri-Tethys region. I didn't put them up, but that's been previously published. So they're probably the global standard at the moment for osmium isotope records for this interval. So it would be good to get some more elsewhere and see, are we seeing the same sort of trends? Yeah.
Yeah, kind of intrigued by the value of CIA. You have free continuum.
Yeah.
How do you reach values that are lower than 35?
Yeah. Well, that's interesting, isn't it? So, I mean, this was just simply plotting the filling in the different values within the CIE equation, and what we're actually seeing is they're quite low. And if you were to use that as if you were to read off weathering just from those values, you're getting quite weak weathering that sort of has this overall increase. So when you think about these sort of sea level fluctuations that are supported within the site, it does look like that looks to me like a coasting upward sequence. So potentially CIA might be reflecting again, the grain size proxy didn't come through as strong a correlation, but definitely the trital feldspar. So potentially there's a maybe changing increased weathering of a particular mature soil potentially throughout the section, and that's what you're seeing. But yeah, it's quite intriguing, like you say, like it's not as what you'd expect it to be, but yeah, that's what comes out when you put the values in. So well, yeah, this is another thing. So obviously the existing data sets, that's something to look into. How were they prepared? Because we don't actually know. I think these studies were done about 10 years ago, so I'm not quite sure if the sampling procedure they took. But yeah, it's food for thought when we're looking at CIA records, things to think about.
One more. Yeah.
Thank you for the talk. And for the PETM CIE and osmium isotope variation. So you also showed the high sedimentation rate during the early PETM, right?
Yeah.
During the transgressive system tract.
Yeah.
So mean lots of heterogeneous material transport to the ocean, right?
Yeah.
So the higher erosion rates, right?
Mm-hmm.
So if it's possible that this higher CIA or higher osmium isotope to related to the erosion weathering of organic rich shale, and these materials have already weathered in the previous.
Well, this is the thing, and I think that's where it comes into the strong correlation with the feldspar, that potentially what you might be seeing here is that remobilized parent material that was already highly weathered, maybe some sort of heavily weathered soil profile that has then been remobilized, and that's maybe what we're seeing here, because the correlation with the typically of all the things that potentially bias CIA, feldspar is not supposed to, but there's a very strong correlation in this record. So potentially what you're seeing is this maybe secondary mobilization. But these are all interesting things to consider when we're working with CIA records, I think that's all. Yeah.
Thank you very much.
Thank you.